Today, Oliver, my cat, is going to help us to do some more simultaneous equations. And this time we are again going to use the elimination method, but there is an extra step we have to do in the beginning. So if we look carefully at what we've got here, we've got a y variable in each equation, and we've also got an x variable in each equation. But they've written them in different order so that we might get a little bit confused, so we're going to also just try and reorder that to make it more user-friendly. Secondly, if we look at the y values, that's got a coefficient of 2 and that's 3, so they're not the same value. That's 2 and that's 3 as well, so they're not the same value. So we've got to try and get either the x's or the y's to become the same value. So if we wanted to make the y's the same, the lowest common multiple of 2 and 3 is 6, so we would have to get them both to become 6. Or we could do the same thing with the x's. So let's first of all start off by numbering our equations 1 and 2, and then let's decide to get rid of the y's. Just for argument's sake, we could do either way. So if I'm going to get rid of the y's, oops, this is going to be a little bit awkward. If we try and get rid of the y's, we're going to have to multiply this equation by 3 because we want that to become 6y. So I'm going to explain everything that I'm doing. I'm saying, right, Oliver's gone to sleep somewhere else, so let's carry on. I'm saying that I'm going to take equation 1 and I'm going to multiply it by 3. So that means multiply all the way through. So 2 times 3 is 6y. 3 times 3 is minus 9x. And that will give me negative 66. And because I've changed the look of the equation, still has the same value, I'm going to give it a new name. And then that alleviates any confusion later on. So to get this y value to be the same as that y value, I need to multiply this equation by 2. So I'm taking equation 2 and I'm multiplying it by 2. And at the same time, I'm also going to get my y's and my x's and my constants underneath each other because it's much easier to process after that. So let's start with that term. 2 times that term is going to give me 6y. Remember, this is a positive 2. And now I need to say 2 times 2x is 4x. And then I also need to say 2 times 32, which is 64. And because I've changed its appearance, I'm going to also change its number. So now I have got two variables that look exactly the same. So how would I get rid of them? I would need to say 6y minus 6y would give me 0. Just as a matter of interest, say for instance this was a negative 6y, then I wouldn't be saying 6y minus y because that would give me 12y. So if the two signs are different, you're actually going to add the two equations. If the two signs are the same, then you're going to subtract the equations. Just think carefully of what would give you a 0 in the end. So again, I'm going to say what I'm doing. I'm taking equation 3 and I'm subtracting equation 4. So 6y minus 6y is 0. Negative 9x minus 4x is negative 13x. And negative 66 minus 64 is going to give me negative 130. Right, that took a moment. I think I'm still getting over Oliver's antics. Right, I don't want to solve for negative 13x. I want to solve for x. So divide both sides for that negative with that negative coefficient. And I'll be left with x is equal to negative divided by negative is positive. And 13 goes into 130 10 times. Remember that we're not only solving for x, we're also solving for y. So you can substitute this x equals 10 into any of these four equations because they have the same meaning. I would look for the one where it's going to be the simplest. I'd probably go for number 1. So I'm going to say substitute x equals 10 into equation 1. When we set it out like this, it just makes it so much easier for the person who's checking the work or marking the work. And if it's in an exam and you set it out like this and they can see what's going on, you are guaranteed of the marks. So I've got 2y minus 3, and instead of x, I'm now going to write 10 equals negative 22. So 2y is equal to, I've got negative 22 on that side. What is this going to give me? It's going to give me negative 30. So negative 30 is going to go across and become positive 30. That means 2y is equal to negative 22 plus 30 is going to give me positive 8. Divide by 2, and y is going to be equal to 4. And then lastly, remember to write down your ordered pair that you found out. X value of 10, y value of 4, and that ordered pair will give you the exact point of intersection if you were to draw these two graphs on a Cartesian plane. Right, I hope that was helpful, and I'm very glad that you've met Oliver, who's always up to antics.